Good morning, everyone. My name is Jay Saldana. I'm Senior Engineer with Icynene-Lapolla, and I have 11:01 Central Time, and I still see some people joining, so we're going to wait probably one more minute before we get started. Okay. Well, once again, my name is Jay Saldana. I'm Senior Engineer for Icynene-Lapolla Spray Foam. Thank you, everyone, for joining us today. Hopefully, everyone's staying safe and healthy. Hopefully, you're inside in a nice, comfy chair watching this presentation. As you can see, we're going to be discussing two main topics today: fire time-rated assemblies and STC assemblies, both related to spray foam insulation. The way this format will go is I will go ahead and give the presentation, and then you may type in any questions you have using your bar to the side, and we can go over these questions at the end, and we will try to answer as many as we can. There will be a question and answer session. Also, I want everyone to know that this presentation is being recorded, and so at the I'm not exactly sure when, but there will be a recording sent back out to everyone who attended so that you can rewatch, or if you need a copy of any of the slides, so that you can see the slides again. So with that, why don't we get started and go through these topics. Let's see what we got here. So our agenda today, we're going to start with the STC subject, sound transmission coefficients, or classes. We'll start with common questions that we receive, our corporate engineering team receive. And I do want to stress one more time, so I am a senior engineer for commercial. On staff, we have Randy Nicholas, senior engineer for residential. We've got John Broniak, engineering manager of our team. We try to separate the categories of issues that come in just for the quickness of service to you guys. But all of us can answer pretty much most questions that come in. So just keep that in mind as a service that we are providing. So we, as a team, see a lot of these questions that we're going to go over first, and kind of explain what information we have or see on details. We're going to data sheets. We're going to give some examples of what STC actually represents in real world, what an STC value represents. We're going to cover the problems with STC testing and as a relying on STC alone, and why there are some problems with that. And at the same time, because of those problems, what information, as those advocating for the use of spray foam, what can we provide to architects, to contractors, to help them better understand real-world uses and real-world scenarios of sound attenuation. And then we'll help go over what testing we have for different STC assemblies. So similarly, just like we have in this format with STC, our hourly rated format is going to follow the kind of the same thing. Common questions. We'll go over some of the testing, some of the definitions. We'll go over the test parameters. What information do we need from our clients? So in other words, based on a lot of these common questions, we need to make sure we all know what questions we need to ask them so that we can get all of the right information. And what testing do we have to serve these hourly rated assemblies? So let's go ahead and get into it and start with STC. So these are the common questions that we get. What's the STC with 5.5 inches of foam? Notice they don't state what assembly. The question doesn't ask whether it's closed cell or open cell. They just want to know 5.5 inches of foam. What is the STC value? Another common question is, how much foam do I need to reach an STC of 50? Again, they didn't state open or closed cell, and they just assume the more foam they use, then the better the STC they're going to get. What's the STC of open cell foam, meaning per inch? How much STC value do I get per inch of open cell foam? Another common question is, how much open cell foam do I need in my ceiling to not hear noises above me? So can I just add a whole bunch of open cell foam in my ceiling to not hear noises above me? And the common thing that exists with all of these questions is that it just doesn't work like that. It's just not that simple. It's not that easy. STC is an assembly test. This is important to remember. It is not a physical property that can be calculated and tested on just a material and then understand how it works in an application. You can get material values, but it has nothing to do with the end result of the application. So it's important that we all understand that STC is an assembly test and that it's not as simple as saying, how much foam do I need to reach an STC of a certain value? Or what's the STC if I have 5.5 inches of foam? It's just not that simple. We're going to cover why that is and help us have a better understanding of how to have these conversations with people who may be asking you these questions. So some of the sources of originating factors that might be causing some of those questions are information that's put out there on different data sheets. These particular two clips from data sheets are Icing and Lapola data sheets, but I think you'll see this exact same type of information on a whole bunch of different manufacturers' data sheets. And what it leads you to believe is that the sound transmission class 41 is specific to the foam that is on this data sheet, or that the noise reduction coefficient of 0.7 is specific to the foam that's on this data sheet. But the reality is that they're assembly related, and a lot of data sheets don't necessarily help explain what exactly that assembly is. And it's important to know that if you change a component of that assembly, then you're going to change the result. If an assembly was tested with 5/8 inch gypsum board and someone wants to build with interior 1/2 inch gypsum board, then you will get a different result. So it's important to know and how to explain to someone that it's not a material-based STC result, that this was achieved with this foam in an assembly, not just the foam is causing the STC. This particular data sheet here attempts to at least show that there is a 2x4 wood stud wall involved in the assembly, but it doesn't tell all the details. It doesn't tell what sheathing was used and how much foam was used. It just simply says STC 37. So understanding that we do have information, but it's really too difficult to list all of the information. Every detail of every assembly is too difficult to list on a data sheet. So we want to inform people that we do have something, but we just can't list everything on a data sheet. It gets too complicated. Let's make sure we understand a little bit about how the STC testing works. So STC, Sound Transmission Class. Sound Transmission Class, that's what it stands for. You may see a listing that says an STC of 37 class. Sometimes they repeat the word class. It simply is just referring to STC. All right. It's an integer rating of how well an assembly attenuates airborne sound. An assembly. You need to make sure you remember that. This is important. An STC of 35 does not mean it stops 35 decibels of sound. So in this example here, we've got a room that's creating 100 decibels of sound, and on the other side of the wall, we're hearing 55 decibels. That does not mean that this wall has an STC of 45. That's not what that means. Okay? So STC is not directly related to how much decibel sound is lessened. So make sure that's clear as well. But what does STC mean? We'll cover that in just a second. This is how it's actually tested. We've got the standard test method for laboratory measurement of airborne sound transmission loss of building partitions and elements. So it's important to understand it says building partitions and elements. So that helps you know it is not just a material, it's an entire wall assembly. But you've got a really large room that is creating the sound, and then you've got a really large room that's measuring the sound. Okay, and in these rooms that are measuring the sound, there's all kinds of this is a very simplistic image, but there are all kinds of sophisticated equipment in there to help direct sound to multiple different microphones. They can measure from different parts of the room. It's a very scientific, complex measuring process. And in the middle here, we have our wall assembly. It gets placed in the middle. Now, we'll cover what the flaws are of this testing. But as you can see from this simplistic drawing, you could probably envision how there are some flaws just in the setup in relation to real world scenarios, how they compare. But that's just how the test works. Sound is created from a source. It's measured in a completely separate room by multiple microphones, and it's passing through an assembly in the middle. So what does STC mean? Here's kind of a way to better understand what the STC value is actually producing. Normal speech can be easily heard if there's an STC assembly of 25. If you bump that up to 30, loud speech can easily be heard. But at 35, loud speech is heard, but it's not really understood. It's more like you can tell people are talking. At 40, loud speech is now only a murmur. 45, loud speech is heard. Music systems and heavy traffic noise is still a problem, but reduced, obviously. And at 50, very loud sounds such as musical instruments or stereo can be faintly heard. And then at 60 plus, you're getting excellent soundproofing. So this is good to know when you're looking at requirements. If you've ever seen an assembly that or a project that requires a specific STC value, what it kind of relates to. And kind of in between these numbers, what is really important to understand when you're comparing one assembly's rating versus another assembly's rating is that the differences between, if I can get my mouse to show up in the right spot, the differences between one STC point, it's almost imperceptible. You really can't even tell, right? The difference between 3 points is just barely perceptible. 5 points, that's clearly noticeable. So if you look at our chart over here, we're going by fives, and so that's how they're defining clearly noticeable. And then 10 points is twice as loud or quiet. So the difference between 40 and 50 is a big difference in STC. But if you have a rating that requires, a jurisdiction that requires a 45, and you have an assembly that has a 43, well, that's only 2 STC points difference. It's between imperceptible and barely perceptible. So that's something that we need to be able to make that argument when we're talking to people, to understand that 1 to 3 points difference is really not making that much of a difference in the overall sound of that assembly. So that's important that we remember that so that we can communicate that in moving forward. Problems with STC testing. So there are quite a few. Let's start with the one that benefits spray foam competitors the most. STC testing requires a laboratory airtight assembly. Remember that image that I showed of the 2 rooms? This wall, this assembly that gets put in between the 2 rooms, has to be airtight because sound travels through air. If you do not have an airtight assembly, then sound might be bypassing your assembly and getting into the microphones. Therefore, you're not really testing the actual assembly itself. So in a laboratory test condition, if you've got a wall filled with air permeable fiberglass and sheetrock on each side, but there are no penetrations in that wall. There's no windows, there's no power outlets, there's no light switches, there's no pictures hanging. Like a real world scenario, you are testing a perfect wall that is not related to real world, where you have penetrations in that wall that allows air to move through. So a fiberglass assembly tested in a laboratory gets the benefit of that assembly being airtight, whereas in the real world, it's not airtight. So these tests are not real world related. Spray foam, on the other hand, is an air barrier material. So when you test an STC assembly with spray foam, whether it's real world or in a laboratory, you're already getting the benefit of the airtight assembly. STC also is not a good representation of low frequencies. STC testing is from 125 hertz to 4,000 hertz. Any audiophiles out there will know that bass is less than 125 hertz. So a lot of bass in music, deep voices, will carry through an STC wall assembly much different than it would if they were higher frequencies. So STC results are not accounting for bass. Another issue with STC testing is that it was invented in the 60s. So some testing out there, some assemblies could be as old as the 60s or 70s. And of course, equipment has become a lot more advanced and sophisticated since then. So results, if those assemblies were tested over again, might not be the same. So we got to ask ourselves, are we chasing a ghost here? Trying to achieve with modern materials, newer equipment, achieve results that fiberglass is getting the benefit of airtight materials from tests that could be 30 or more years old. So are we chasing a ghost trying to even achieve those results that really don't work in today's world? So we have to make sure we keep that in mind. So with all those issues, what is it that we should communicate? Icing-Lippold has developed this basics of acoustics document here, acoustical construction, and it has 4 main points that we want to make sure everyone can explain to aid in the benefit of understanding the difference between real-world STC and the testing STC. So, for example, increasing the mass of the wall. We've got a graphic here that shows a thin wall with lots of sound on both sides, and then a thicker wall, a more massive wall with less sound on the inside, this being the outside because it's got commercial building making noise. So by increasing the mass or weight of a wall, you can decrease the amount of unwanted noise. It is typical that by doubling the weight of a wall, you can attain sound transmission loss of 6 decibels. So using 5/8" gypsum board instead of 1/2" gypsum board is a good example of this. So we talked about that earlier. Using a heavier gypsum board rather than your standard 1/2" gypsum board is a way to help achieve better sound attenuation. If sound attenuation is important to your job, it's worthwhile explaining that. Hey, on your exterior walls, instead of using 1/2" gypsum, use 5/8. You're automatically going to increase sound attenuation. Boom. What else can you do to increase sound attenuation? You can decouple the system. So here we've got a wall that is all touching itself. You got wood studs, you've got insulation, you've got interior and exterior sheathing, it's all touching. The sound can vibrate right through those materials and go right through. Decoupling, this wall has an airspace inside. You've got some insulation on one side, spray foam adhered to this wall, and then you have airspace before the sheathing of the other side of the wall. That airspace decouples the vibration movement. The vibrations move through the insulation, they hit airspace, vibrate in the air, and then not as much sound transfers through. Sound is energy. When this impacts on a wall, it sets the wall into vibration. This vibration carries the unwanted sound through to the opposite side. So another way, rather than having airspace inside the wall, is to change the way that the sheathing is fastened in this wall assembly. If the interior sheathing is fastened with resilient channels or furring strips, that is another way to decouple the surface area contact with the studs. Again, if you have our first example with increasing gypsum from 1/2" to 5/8", and a second example of using an airspace in the assembly or a resilient channel or furring strips, you've already dramatically increased the STC of this wall just by doing that all by itself, those 2 things. A third thing is using an absorptive material. So here we have an assembly with open cell spray foam inside, which absorbs the sound energy and doesn't allow very much of it to transfer through. So as you can see, you've got noise on the outside of the wall. As it's moving through the absorptive materials, you've got less on the inside wall. So lightweight insulations are good sound absorbing materials, and conversely, heavier, denser insulations tend to reflect the sound back. So lightweight can be considered open cell, heavier, denser can be considered closed cell. So closed cell would help reflect this outside noise back to the outside, while open cell absorbs it and prevents it from moving through. Fourth way is air sealing the wall. Like I mentioned earlier, sound moves through air. If we can air seal an assembly, like using spray foam, then we can prevent sound from moving through the wall. In real world, fiberglass, batt insulations, even cellulose blown-in insulations, they will settle over time, and there will be airspace, air pockets that allow sound to move through. you can see that while fiberglass does reduce the sound, a air barrier system would reduce it even more. So something we need to be pointing out, of course, we are advocating for spray foam. Therefore, we want a nice air-sealed wall for many reasons, sound being one of them. Again, in this document, it also points out that in the real world, walls are far from perfect. Walls can have numerous acoustical flaws in them. Items such as electrical wiring, switch boxes, outlets, piping, all make sound control more difficult. Beyond providing a sound absorption material, I think Napola open cell spray foams fill a wall in ways that fibrous bats cannot, adhering to the substrate, wall framing and sheathing, limiting the ability of sound to bypass the insulation. Noise like water and temperature will move through gaps. Icynene Napola open cell spray foam work as an air sealing element as well as an acoustical insulation, limiting the effect of real world acoustical flaws. So again, this paragraph is kind of encompassing everything that we've just talked about. The issues with STC testing, the fact that fiberglass is getting a benefit of the test method, and the fact that real world has many, many variables involved. So final summary here of what do we communicate. Open cell foam shows similar, if not better, performance than fiberglass. Icynene Napola open cell foams vary in density. So there could be 3/4 pound to 1/2 pound, but we find that they have very similar performance. The 3/4 pound foam that we're getting ready to show you, the testing that we have, was tested at 2 inches. So that's because that is an air barrier at a minimum 2 inches. So if you're using foam for air purposes, for sound purposes, the 3/4 pound product can be used at a minimum of 2 inches to achieve that sound air barrier result. Open cell foam absorbs sound while closed cell foam reflects sound. And just to point out, there exists very minimal testing with closed cell foam in the industry for STC results. So most STC results are going to be with open cell foam. So in kind of a old to new process, we've got our company has testing, and we want to give you kind of an overview of just some examples of some of the STC testing we have. You can see over here, we've got a wood stud assembly filled with open cell foam to give you an STC of 37. And over here, we've got a metal stud assembly using open cell foam, but it doesn't fill the whole thing. But you've got 2 layers of gypsum on each side to give you kind of an R40 or an STC of 48. So two different examples: a wood stud with single layers of gypsum, steel stud with double layers of gypsum to give you an STC of 48. Remember, STC is assembly based. So if you were to change something in these assemblies, you would get a different result. Case in point, here is an assembly over here. We've got steel stud with 1 layer of gyp on each side, wood stud with 1 layer of gyp on each side. Each of these are using the 3/4 pound foam at only 2 inches. So if this is an interior wall, partition wall, that they're trying to achieve a certain STC, you can get a 35 here. You can get a 33 here. So wood stud 33, steel stud 35. That's only 2 inches of that 3/4 pound foam. Just an example of some of the testing we have. Similarly, this test result is very similar, but on one side of the wall, you've got 2 layers of gypsum. So you're trying to achieve a slightly better value by increasing the mass of the wall. And you can see that did give you several STC points better. Decoupling the system. Here is a double steel stud assembly where the studs do not touch. And you've got 2 layers of gyp on each side. So that's getting you way up to 56. And again, we've only got 2 inches of the 3/4 pound foam in here. Same thing with the wood stud, decoupled, 2 different sets of studs, decoupled, 52. Again, with only 2 inches of that 3/4 pound product. So just several examples of what the testing we've done with STC. Wanted to point out that we actually did a second test on this wood stud assembly where we used 1/2 pound foam at 3.5 inches on this assembly, and we're able to achieve a 53. So slightly better than the 2 inches of foam. We used a normal 1/2 pound foam, 3.5 inches of foam, and got a 53. So just another example of some of the testing we have. One thing that we want to point out as we're finishing up the STC section is that engineering evaluations are currently not available. Our company can't provide them, and similarly, we have not been able to provide third-party acoustical engineers that are willing to provide an evaluation for STC assemblies. This simply points to the fact that STC can change dramatically depending on what's in the assembly. So that being said, it's impossible to expect any manufacturer to have a test for every single assembly out there. That's why it's important to know the different ways that STC in real world can be affected: increasing the mass, decoupling the system, using absorptive materials, and having an airtight assembly. All 4 of those things we need to have on the forefront of our mind when we're discussing STC with anyone out in the field. All right, so that finishes up the STC portion. I'm sure we'll have a few questions. Remember, feel free to type them and send them in, and we can go over those at the end of the presentation here. We'll have some time for that. So for now, let's go ahead and move on to the hour-rated assemblies. So just like STC, we're going to start with common questions. Do Icynene products have rated assemblies? Send me your UL listings. Just a simple question asking for all those listings. Can I use Lapola products in my 2-hour wall? Can I replace the fiberglass in my roof assembly with open or closed cell foam and maintain the hourly rating? And another common question, how much foam do I need to reach a 1-hour rating? This one's more common than I'm happy to see because it's unfortunate. But similarly to the questions related to STC, it's difficult to create lists. So where a lot of people just want to have a list of all of our UL listings, it's very difficult to come up with that list, and we'll talk about that, why that is. And then it's important to know that foam is along for the ride. So it's particularly related to this last question here. Spray foam insulation, in fact, foam plastic insulation in general, rigid board foam, XPS, EPS, polyisos, and spray polyurethane foams, open or closed cell, do not create hour ratings. They do not create time ratings. They are combustible. They are along for the ride. All those products are relying on other materials to create the hour rating. It's important that we can convey that simple message, because someone may be thinking, hey, I need an hour rating in my ceiling. How much closed cell foam do I need to create an hour rating? We need to be able to stop them right there and say, look, no spray foam product, no foam plastic insulation product is going to create your time rated assembly. You have to rely on other materials for that. Same thing with UL listings. We'll get to that in a second here. But just like we did with STC, let's look at what we see on the data sheets that might help understand a source for these questions. We state in multiple manufacturer data sheets, not just Icynene and Pola, our industry states that there is compliance with 1 and 2 hour ratings. We state that we've got 1 hour wood stud assemblies and 1 hour steel stud assemblies. But in both of these data sheets, you will note that we say consult the engineering department, consult the technical group. That's because it's just not as simple as saying, yes, we have it. It's an assembly-based test, just like STC, and it depends on the assembly, and it depends on the product and where the product's going and how much we're using. So knowing that, let's just, before we get into what we have, let's make sure we understand what these hour-rated assemblies are. It's ASTM E119. Okay, that's the very common term for time-rated, hour-rated assemblies. The standard test method for fire tests of building construction and materials. It's an assembly test. All right, that's important. We got to remember that. And here's what it applies to. So there's a floor ceiling test or assembly. There's a roof ceiling assembly. You can actually have time-rated assemblies related to beams and columns. And then you can have walls and partitions. So walls is intended to mean exterior walls. Partitions is intended to mean interior walls. So all of these different assemblies can be time-rated for 1, 2, 3, 4 hours, whatever the particular application requires. So we need to make sure when we're talking with someone that we understand what assembly are you even referring to when you ask us if we have any time-rated assemblies. Which type are you referring to? We need to make sure we know. We need to ask that question. How the testing works. There is a permanent structure like this or like this. This one's for walls. This one's for ceiling, roof type applications. This one's horizontal. This one's vertical. There are thermocouples inside. Fire is produced at these different locations, at the squares, just like these squares. And your assembly is built and then pushed up to this wall or laid down on top of this horizontal assembly. And then the fire occurs. And so that's how the test occurs. That's how it's actually tested. You have a permanent structure, the fire is created inside, and your assembly is pushed up to it. Now, during that fire, it's a temperature curve that is created in that assembly. It's, if you have an hour-rated assembly, you're going to go up this temperature curve for an hour. So between 30 and 60 minutes, you're going from 1550 degrees to 1700 degrees. That gets pretty dang hot. As you can see, temperature keeps increasing, though it starts to flatten out, but it still gets pretty dang hot in order to achieve these hour ratings. It's very difficult to pass this test. A couple interesting points. It's not just the fire and the assembly maintaining its composure during that fire. The unexposed side has to remain below 250 degrees Fahrenheit. And once the time rating is up, there's actually a second portion of the test where the assembly undergoes a fire hose water spray. It has to remain in place during that fire hose water spray. So the whole point of this is to let you know that sometimes it may be thought of, hey, you don't have a particular assembly. Why don't you just go do the test real quick? There's a lot that goes into these tests. The fact that the other side has to remain below 250, and you still have the hose spray beyond this extreme heat. There's a lot that goes into them. So it's important to know that it's not a simple test. One thing that I want to make sure to point out, metal transmits heat. So when you have metal on the fire side of an assembly, that's going to transmit heat right through. A lot of times I get asked the question, for example, metal buildings. Those cheaply constructed metal buildings, they might be close to another structure and they might need a time-rated wall. We're not aware of metal assemblies that are meeting these requirements without a bunch of non-combustible materials inside of that assembly. So remember, spray foam is not a non-combustible. Spray foam is combustible. So if you've got an assembly that's using a lot of metal sheeting on either side, it's probably going to be very difficult for spray foam to be inside of that assembly and maintain an hour rating. So just want to point that out there. What information do we need to know? Remember, based on those questions, we don't get a lot of information. We have to be able to ask them these questions here so that we have a better understanding of what it is they're looking for. So what are they trying to build? Let's just start with that. Do they have a wall or a partition? If it's not a vertical surface, do they have a roof ceiling or a floor ceiling? So we need to make sure we understand that. What existing UL assembly listing are they hoping to meet? You know, this is an important question. Remember, spray foam's along for the ride. The other materials need to meet the hour ratings, time ratings for us. If they don't have an existing assembly that can create that hour rating, adding spray foam is not going to create the hour rating. So if they don't have any idea, tell them they should ask. Ask the designer to choose one. The designer may not have one. They may be doing this from their home. They may not be working for a company. This may be the first time they've come across this issue. Tell them to go try to choose one that closely fits their assembly. If we can get that UL assembly, then we have a starting place to determine whether or not our spray foam can be inside. If they can't come up with that UL assembly, then ask them if they can provide an assembly section, whether it be a wall or for a roof. If we can get that section that includes, maybe they draw it, maybe it's not, maybe it's a hand sketch, maybe it's not a copy, but even a hand sketch is useful to be able to understand what studs, joists, or trusses are being used, whether it's, you know, is it a 2x10 joist, or are they using a parallel cord truss, or, you know, all that information matters in these time-rated, fire-rated assemblies. What sheathing are they using? Is it wood? Is it gypsum? Are they planning resilient channel attachments? These could be I-beams. So I-beam joists and resilient channels are very useful if they have that. What sort of cladding and finishes are there on the interior and exterior of the walls? All that stuff matters if we can get either a sketch or have someone provide an actual assembly wall section. That would be extremely useful in being able to determine if our foam can go into that assembly. And of course, this is a huge headache when people don't even tell us what foam product they want to use. It's extremely important. We got to know, we're selling foam here, we're advocating for foam. Which foam are we wanting to use in this assembly? Let's make sure we, at a minimum, identify that. But the rest of this is important. If we can know this information, then we can have a much easier time determining if our spray foam can be inside of that assembly. Just some other information to know. I've mentioned this before, but I'm going to repeat it. No foam plastic insulation product, that's spray foam or rigid board, creates or adds to the time rating. It's along for the ride. Along for the ride here, okay? It's important to know. We have to be able to communicate that to people, make sure they know that the other materials in the wall need to create the rating. And then we need to know this, that the majority of the spray foam industry does not have hourly rated listings with UL, the vast majority. There are only very few UL listings that even include spray foam. The entire spray foam industry goes to market relying on engineering evaluation letters, otherwise known as EEVs, from third-party fire consultants. Most common, that's Priest & Associates or Hughes & Associates. So we rely on third-party evaluation letters. We take those UL listings that they're trying to meet, and the fire consultants determine, hey, can we put the spray foam in that assembly without detracting from the existing rating? Because the existing design is intended to create the rating. Maybe they had fiberglass bats in the existing design of that UL listing, and these third-party fire consultants will determine if you can put spray foam in there and maintain the rating. And then it's also important to know that previously written EEVs are accepted elsewhere because, let's face it, fire does not know what year it is or where it is. It doesn't know if it's in residential construction or if it's in commercial construction. It doesn't know if it's 2000 or 2020. If the assembly is built the same, then the judgment remains. If it's the same products, the same assembly, the judgment still remains. So previously written EEVs are accepted by building officials all over the country. Similar construction produces similar results. So that's important to know. We don't have to get a brand new evaluation for every instance. So what do we have? So here's an example of what a Priest and Associates engineering evaluation letter would look like. Just obviously it's just the start of it. There's details below, but it's addressed, it's dated, but again, it's acceptable to use these letters over again, and we do. The industry does, not just icing in the polo, the industry does. So this is how we go into market with engineering evaluation letters. From engineering evaluation letters, as an example, icing and Lapola have approvals for a very common wood frame. This is just some of the approvals we have. We have a bunch of them. I'm just going to go over several that are very popular. A U356 wood frame construction. We've got a U425 steel stud construction. Kind of looks like this, multiple layers of gypsum. This is a 2-hour rated wall, and it even uses exterior insulation on the outside. Another popular one is the P522. This is very popular in commercial construction, like made out of wood frame. So like apartment complexes, assisted living centers, nursing homes. This is a very popular one where we can put the insulation underneath the roof deck, create an unvented attic, and maintain the hour rated roof ceiling application. So this one's very popular. We've also led the way, the industry, icing and Lapola has, in doing testing for a shaft wall. So for those that aren't familiar, a shaft wall is a kind of an area separation wall made with 2 layers of 1-inch thick gypsum in the middle. This is most commonly used in townhomes or condos to separate one unit from the other unit. Now, what's unique about this, so this testing has given us many different approvals for many different UL listings. However, we are not listed in UL. So we have the engineering evaluation that shows that all of these listings are now approved. What's unique about this assembly is that if fiberglass, let me make sure I make this clear. This circle down here is exploded into 2 different sections. We're looking at a fiberglass version here and a spray foam version here. The difference is the requirement for this assembly is that the fiberglass does not require a 3/4 inch airspace. It does not touch the shaft liner. Our testing allows the foam to be sprayed in and around this stud and directly onto the shaft liner, which makes application extremely easy. You install the shaft liner first. Whenever installation is taking place, you just come in and spray the foam as necessary. That 3/4 inch air gap is not required. So that's a big difference. It makes it a lot easier to install. When you incorporate that with STC practices, you now have a much better airtight assembly between units. Again, leading the way, we've got testing with Intertech. So we've got hourly rated assemblies listed on Intertech's website. So these are assemblies that you wouldn't have to use a third-party fire consultant for. And these are just some examples of the different testing that we have. Obviously, I want to make sure to point out that we've got a lot more, but these are just some examples. And so with that, that completes the presentation. And so what I want to do now is go to the questions here. make sure people are have an opportunity to ask these questions. We've got several here, so let me read through these. So someone's asking if there's a recorded version that they can watch later. Yes, there is. That will be sent out with the follow-up email whenever that email comes from our marketing department. Let's see. Got another question here. So here's a question. Often we are replacing fiberglass with spray foam. So if you're replacing an R19 fiberglass, is it safe to say that an R19 open cell would have similar STC as fiberglass in the same assembly? So in other words, you're not changing anything, but you're just going through and changing the fiberglass to open cell. And the question is asked correctly. Is it safe to say? And the answer that we have is yes. When you look at the testing that we do have, whether it be our older testing or our newer testing, these results are very similar to what fiberglass produces. So these results in particular here, when you're looking at a full stud fill, we've got 3.5 inch. So for example, this is an R13. So if you were to have an R13 bat, many of the UL listed STC results for fiberglass is going to be right around this exact same number. Remember that plus or minus 1 or 2 STC points is not going to be noticeable. That's something we need to be able to communicate. If someone's saying, yeah, but they got a 38 and you're a 37, it's not noticeable. We need to make sure we can make that clear. It's not noticeable. Another question. So in general, the answer is yes. We see that our open cell product is producing very similar results, sometimes with less open cell. For example, I'll make sure to point that out. This testing here, where we did 3.5 inches in a double stud wall and achieved a 53. It's important to note fiberglass uses 3.5 inches on both sides of the wall, both sides, 3.5 inches, both sides, and achieves a 54. So here we are with 3.5 inches of half pound on one side of the wall only and achieving a 53. So in many ways, we like to say it's equal to or better than fiberglass. It's all going to be situation dependent though. Another question, do we have a STC for a 2x4 wood stud 16 inch on center? So yes, that question is yes. We've got that here as an example. This is 2x4. We've got several different ones of these. Here's a 2x4 with 2 inches of 3/4 pound at a 33, and here's a 2x4 with 3.5 inches of half pound at a 37. So the answer is yes, we do have that. So the question is, does Icynene and Lapola have the same time rated listed assemblies? That question is, the answer to that question is no. Currently, they don't have the exact same. However, it can be for throughout the history, part of the time rated way we go to market is through EEVs. Icynene has had more EEVs created. So while it is possible for Lapola products to achieve the same results, they just don't have as many EEVs created yet with their name. So when these situations come up and time-rated assemblies are necessary with Lapola products, we can look at what it would take to have these EEVs essentially, let's say, duplicated with the name of Lapola products. It's not going to be free, but it can be achieved. So the answer to the question is yes and no. It's mostly based on the fact that the Icing brand has been having these EEVs for time-rated assemblies created for just a lot longer. Another question, do hotels go for a certain STD between rooms? The answer is yes, they do. Many hotels, it depends on how they're constructed. Many hotels are built out of wood frame, and they're about 4 stories tall. It's just kind of the break point between types of construction between wood and moving up to steel or concrete. So these wood frame walls do need STC value between them. It is a good push. It's advisable. We would be totally on board with going to hotel manufacturers or whoever, contractors, and trying to market our spray foam in those wall assemblies. Now, what STC they're trying to achieve, I don't know. They do obviously have a lot of experience. They've been building them for a long time. So it is something to think about, consider open cell foam in those wall cavities. Great question in hotels. Personally, as a side note, I think everyone should be hitting up all hotels, contractors, manufacturers, owners at all times, because a hotel is responsible for the energy bill, but they're not responsible for controlling the temperature in each room. So you would think that they want those rooms to be as energy efficient as possible, because that lowers their costs by lowering their electricity. So it makes common sense that hotels should be built as energy efficient as possible. I highly encourage anyone on this call to take an opportunity to try to speak to people at hotels about these opportunities. Another question, is there a similarity in STC between open cell foam and dense packed cellulose? So the answer to that question is there probably is, but I don't know what that similarity is. Dense packed cellulose and mineral wool type products do usually perform better than fiberglass, which means they do have a potential for performing better than spray foam in the laboratory tests. Because remember, these are not air barrier materials. Mineral wool, dense packed cellulose, they're not air barrier materials. So in a laboratory test where it is air sealed for them, they get good results. In the real world, when you add in everything we've been talking about related to this basics of acoustics document, whoops, passed it, sorry, wrong way. When you add in all 4 of these points, it's entirely possible that spray foam keeps up to it in the real world. So I think it's important that we utilize these points, this document, ask for it, make sure you have it. It is available. We can send it out to everyone on this call to aid in the fight against those other materials. Let's see, another question. So the question is, how efficient is it for a contractor to use only 2 inches of spray foam? Well, so board foot wise, I honestly don't know that answer, but the concept is that a lot of, just like the hotel question, a lot of soundproofing is not necessarily from the exterior in. 2 inches of 3/4 pound is only an R8. So it's not going to meet the energy requirements. But what it is an air barrier material, and it is an open cell foam that is sound absorption. So from that, the 2 inches, let's see here, is meeting the sound absorption material. It's decoupling the system by putting an airspace, and it's an air sealing in the wall. So 3 out of the 4 are met by using the 2 inches of the 3/4 pound. So if you have an office building that has interior walls that want some sound deadening ability, boom, right there. 2 inches, a 3/4 pound. You don't have to fill the wall because honestly, you want the 2 inches so you can get the airspace and decouple. So that's the viability of that testing, and where the concept that why that came from. Another question here. We're running out of time, but I have good questions. So those who need to drop off, feel free. But there is another question here. On an area separation wall application, what are the cost differences and advantages to combat fiberglass? Obviously, a better system with foam, but is the cost that much better? So on the area separation wall that we were talking about, the advantage is that it actually takes quite a bit of effort to get to, hang on, let me get to the slide, almost there. It takes quite a bit of effort to install this fiberglass in a manner that it is not hitting these assemblies. Spray foam, you can just come in, you don't have to fill it full cavity, especially if you're putting foam on both sides of the wall. Now, you don't have to put foam on both sides of the wall. Some jurisdictions will let you insulate one side. So that can be a cost savings. And again, just like we try to market in every home, time is also a saver. If spray foam can go in faster, then that is a money saver compared to fiberglass, because this may be difficult and time consuming to install. So, okay, so that actually rounds out the questions there. I really appreciate everyone for joining, and we thank you for your time. Again, this is being recorded, and a link will be sent out in the follow-up email. So we look forward to seeing everyone next quarter. We do these presentations quarterly, and hope everyone stays safe and go out there and make some sales. Thank you for your time. I appreciate it. Have a nice day.